Fifth graders, I am your teacher. Yeah, totally going stir crazy. I know, crazy town. Anyway, guys, I came today to talk to you a little bit about our new unit, which is force. So I have some handy dandy little cards. These are actually going to be very helpful if you're unable to print the notes that I put with the lesson. Then these are great because these are actually the exact same things and we're going to be talking through them. I hope you love the butterflies. I am in my daughter's room doing this today. She would be furious, but she's not here, so she doesn't know. Okay, so let's kind of go over the key points and then you're going to have some work to do on this on your own once we finish up. All right, so force. Force is a push or a pull. So whenever you do anything, basically, you're going to have something opposing what you're doing. So forces always act in pairs, which I will get to in a minute. But a force, push or pull. All right, so forces can do a whole lot of things. They can make objects start moving and they can make them stop moving. So let's think of like a soccer ball, for example. If I have a soccer ball just sitting on a field and it's stationary, it's not doing anything, it's just still, there is force still acting on that because there's the force of gravity. Now, if somebody goes up and kicks that ball with their foot, they've applied a new force to it. They've changed the object's motion or direction. So forces make objects start moving and make objects stop moving. As I said with the soccer ball, they also change speed and can change direction because if that ball was just sitting there, it didn't really have any speed attached to it. But as soon as I kick it, I'm going to change the speed of that ball and I'm going to change the direction that it's traveling. Forces always, always, always work in pairs. You can't just have one because then there's nothing acting on something else. You have to have them in pairs. So here's my forces always act in pairs card. So make sure you can see that. All right, so let's recap what we've got so far. A force is a push or a pull, makes objects start moving and stop moving, can change speed or change direction, and forces always work in pairs. All right, so far so good. I know I'm not the best camera person. Good? All right, let's keep going. So to have a force, it can be a balanced force or it can be an unbalanced force. If it's a balanced force, we know because of this. So a balanced force won't change an object's motion or direction. So if I am that ball that is just on the field, I'm a balanced force. I'm just hanging out. Gravity is pushing down on me, but nothing's happening. It's just I'm stationary. I'm not moving. Now, we can have balanced forces that do move, but the reality is it's sort of a theoretical because we have friction, which we'll talk about in future lessons, and friction opposes motion. So on Earth, it would be pretty difficult to actually have a true balanced force because once you move something, friction starts to take hold and then that works against its motion. All right, let's look at an example for my balanced forces here to really kind of see it at work. So you can see I have two triangles and they're on a little balance beam there. There's the same force on this side that there is on this side. And so the forces are balanced, they're equal in size, and they're opposite in direction. That goes with my balanced force. All right, if I'm not a balanced force, then I must be an unbalanced force. So unbalanced forces change an object's motion or direction. So when that person kicks that soccer ball, then that is going to be an unbalanced force because their foot applied more force. The ball could not resist that change and it went flying forward. So it changed its motion. Our example for unbalanced would look kind of like this. So you can see we've got a larger mass object here, which is applying more force. We have less force here, And because of that, they're unequal in size, but they are coming from opposite directions in this case. So since I have an unequal force, then that means that this little guy is having a change in motion, because as soon as this one applies more force, it makes this guy go up. All right, so I'm going to show you our graphic here one more time, and we're going to talk through, make sure we've got it before we move on to one particular force that's very important on Earth. All right, so let's go in nice and close again. All right, so again, a force is a push or a pull. Makes objects start moving, stop moving, change speed, or change direction. Forces always work in pairs. Balanced forces don't change an object's motion or direction, and you can see there's an example of my balanced. Unbalanced forces change an object's motion or direction, and then you can see my example. This would be really good to use later today, guys, because I put a little sheet in Google Docs, and you're going to practice determining whether something is a balanced or an unbalanced force. So if you're not sure, come back and look through here. If you can't see the notes that I attached, that will be really helpful. All right, before we leave, we're going to talk about one more specific force that is very common. We've known it forever because we were born on Earth. And that force is gravity. Gravity is the force that attracts objects to each other. Even in outer space, there's gravity. You know, a long time ago when I was a kid, people used to say, well, gravity doesn't exist in outer space. Well, that's not true. There's a different amount for sure, but there's definitely some gravity. All right, so let's see. Where can I put this? Put it here? I'll put it here. All right. So gravity is the force that attracts objects to each other. So there's three things that really impact gravity. So we're going to talk about those three things. Now, most of these are words we've heard and we've talked about before. So they're not going to be shockingly different. It's just making sure we understand and know how gravity relates to those things. All right, so the three things that impact gravity are, let's see, I know a lot of dead air. Mass. We all know what mass is. We've talked about mass before. Remember, mass is like the amount of stuff, of the amount of matter that is inside of an object. It cannot change. Mass will stay constant. So here's our one, mass. The amount of matter in an object, it can't change, won't change. So the way that mass impacts gravity is if something has more mass, then its pull of gravity is going to be greater. So if we take a look at my card example here. So I've got this card, and we can see, and I just kind of made them as circles. You can pretend they're planets or whatever you'd like. But these and these are being pulled together. And you can see that B has way more mass than A does in my picture. But their distances are pretty much the same apart. So given that case, which one do you think will have greater gravity? Think about it, think about it. Hopefully you said B, because B has more mass, and because of that, the pull of gravity is going to be greater between B and that little planet than it is between A and that little planet. So that's our example so far. All right, the next one is weight. Now, oftentimes we think of weight almost the same as mass, but it isn't, because weight is the measure of the pull of gravity on an object. And so weight can change where mass can't. Because remember, guys, mass is what an object is made of. Well, weight is the measure of the pull of gravity on an object. So if you're on a different planet, you're going to weigh a different amount. So weight can fluctuate and change, but mass cannot. Mass will be constant. Okay, the last thing that plays an impact with gravity is distance. Now, distance is how far apart objects are from each other. And the reason distance is important is because of this. So you can see I used my little planet examples again, and I had to write C here and D here because my circles were pretty tiny. But you can see both of those little planets, or whatever we call them, circles, have the same mass, approximately, right? And we're now comparing the distance. Well, since C and this little guy are so much farther apart than D is from that little guy, then that means that D has the greater gravitational pull because they're closer together. So the closer two objects are to each other, the greater the gravitational pull will be, or the more mass the more mass an object has, the greater its force of gravity will be. In 5th grade, I won't ever ask you to think about like, well, what if like the mass is this and, what if like the mass and the gravity, or the mass and the distance, we won't ever compare both of those. We will either look at the mass of the objects being different, but the distance is the same, or we will look at the distance being different, but the mass is the same. We're never going to switch it up between those beyond that. All right, so let's review and make sure we're good with gravity. So gravity is the force that attracts objects to each other. 3 things impact gravity. We've got mass, we've got weight, we've got distance. Weight is the measure of the pull of gravity, and it can change depending on location. Mass is the amount of matter in an object, and it cannot change. But the more mass an object has, the greater gravity. Distance, how far 2 objects are apart from each other. And you can see that D is closer than C, so therefore its gravity is greater. All right, guys. So when you go to today's lesson, you're going to see that there are some, I think there's a brain pop you have to watch, and there's a worksheet you have to do. But basically, we're going to kind of wrap our quarter with looking at balanced and unbalanced forces and gravity. So when we come back from track out, that's when we'll take a look at friction and inertia and some of these other principles that surround force and motion. So good luck, get started. Let me know if you have any questions. And in the words of Yoda, do or do not, there is no try. I'll see you soon.